Alright guys, they're going to be starting some tariffs tomorrow. There's already some tariffs in place, and so I stayed up late last night trying to figure out what the hell I needed to order for some of these projects. And I was able to buy most of what I need to build this DDS VFO for about 30 bucks. I'm still missing some stuff. So this guy here, the Circuit Secrets dude, it'd be nice if he made like a schematic, how he hooked up his encoder and all the other stuff. He's got like a website on Wix, but it's only for one of them. It's not for the Arduino, it's for the Pico. And but anyway, he shows this diagram here. What I ordered a kit for like $6. I don't know. I think you get like 10 voltage regulators. I'm not sure. I'm not certain I want to use a 5-volt regulator, because these things I think can operate on the range of about 3 to 5 volts. I'd like to be under 5 volts. I don't want to be at the top of it. I want to be in the middle. So if I can design one of these to where it get about 4 volts out, I think that would be a little more safety margin. But anyway, so what I ordered was a bunch of stuff on Amazon, and I bought like the cheapest stuff I could buy without buying too many of certain things. I don't know. If we watch this video, like, let me see if I can click on it. Okay. He shows the encoder here, okay? There is a clock, a DT, a switch, a plus, and a ground. And he's using, I think what they call a micro. It's not a nano. It's like a micro pro or something. It's slightly different. The other day I was wondering about these things, you know, they had more than one clock on them. I'm like, is it possible you can use the other clocks to do other things, like for like sideband or whatever? Anyway, so the display to me seems pretty simple. You've got a couple of wires. I have to look and see if I have displays, because if I don't, I'm going to be in trouble. I know I've got one that Andrews sent me, and I think I ordered one that came with some extras. I don't know, maybe I just ordered one. And then I have one from one of those automatic antenna tuners that I built, where you order the case and it comes with an extra display. So I need to find that. So I do have at least 1 or 2 displays. I don't know if they're like going to be the right size. We're probably not going to cram this into a radio, even though like that would be nice to do. So this guy does 2 things. He uses an opti-coupler, which I did not buy. And I don't know what the importance of that actually is, but he's using an opti-coupler down here. And he's in a regulator here, and the idea is that the radio will feed this thing 12 volts and it'll regulate it. I don't know about the regulator. Probably would generate a little bit of heat. I don't know how serious that is. So we did the clock signal going out to the radio, and then I don't know what this opti-coupler is actually doing. I don't get it, but a lot of this stuff I'm gonna kind of have to figure it out on my own. So he's got the channel selector all like way off to the side too, which is also something I don't want to do. You see that big hole right there? I don't want to do that. Now, if I use one of these radios, which I have one sitting right here that I've been working on, is an exact radio that he's basically using. I have a 25 and I do have a 21. my 21 is bad. And I took parts out of it yesterday, if you saw in the video, to try and resurrect this 25. I could probably fix both radios, but I've already removed the microphone connector from the 21, and the 21 had a no transmit condition. The 25 has an intermittent receive problem, so I decided to use that one. But anyway, so we do have these type of knobs, and they're going to use the flat shaft. What I wanted to do was make sure my encoder included threads and a knob and some other stuff. So depending on how I decided to do it, well, the problem is it would never work with something like this because that thing's sitting way down in there. So you need to remove this piece. You have to cut all that plastic out. And it's, I've got an actual, like, newer 25 case of, like, a 2008. Somebody busted it up a little bit, but, I mean, we probably could use that on the 21. I mean, if we really wanted to, we could put it on the other 25. And let's see, what did they do? They combined the volume and the squelch on the one. Whereas the side mount one is volume, squelch, dynamic, and RF gain. But my point is I could use this to cut it up and do whatever I wanted with it. And you could move the mic to the front. I mean, like, there's enough stuff here I could really just do whatever I wanted. It wouldn't be probably worth it, but it could be done. So, anyway, based off of his videos for these, it's a pretty good start. For somebody that's never done this, so it gives me a little bit more to work with because he's using the same thing basically. They both use the same board, but there's differences between older ones and newer ones. The boards aren't the same. So the main reason that I want to follow his design closely is because he's provided the sketch for CB radio. There's another guy, Caesar Sound, and he's provided the sketch that's basically the little DDS VFO. And that's for ham mostly only. So with this guy here, it's a little bit easier to kind of figure out. Now, I wanted to take a look at his opti coupler, and let me see if we can back up the video and see what in the hell he's actually talking about. Let's make sure we got our volume up. So let's go ahead and check this out.
In this diagram, I then added an opto coupler to protect the Arduino from any voltage present on the transmit switch of the radio. I wired...
Okay, why would you need to protect it from any voltage on the transmit switch? I don't understand. Maybe I'm missing something here. Well, why would this be hooked to the transmit switch? I don't get it.
The optocoupler to pin 13 as shown in this diagram. I performed this mod on this radio because the LED display had failed and it was a large enough radio to fit the VFO inside the case. This is a photo of the chassis of the radio from any voltage present.
Okay.
The first step is to add a couple of components to the VFO. First, I needed to add a 5-volt regulator because the radio 6 BP PLL chip. Different years of production use different chips, so confirm your radio has the same PLL before attempting this modification. The first step is to add a couple of components to the VFO. First, I needed to add a 5-volt regulator because the radio operates on 13.8 volts. The VFO requires 3 to 5 volts and any more would cause damage. I added the 5-volt regulator as shown in this diagram.
See what I'm saying? 3 to
I
5.
then added an optocoupler to protect the Arduino from any voltage present on the transmit switch of the radio. I wired the optocoupler to pin 13 as shown in this diagram. I performed this mod on this radio because the LED display had failed and it was a large enough radio to fit the VFO inside the case.
He's keying
This
it
is a
up
photo
on
of the
transmit.
chassis of the Cobra 21 LTD Classic. You can see places where extra components could be installed but are missing here and
Does it
here.
really need to be turned
I did
on and
not
off
remove
during
those components,
transmit?
but they were only popular.
I mean, you need it on receive, too.
The Cobra 25 LTD Classic, and not the 21.
So he must
This
be
is because the Cobra 25 has
doing
no
something
features
weird.
such as RF gain. This is a schematic for the Cobra 25 LTD Classic. I used this schematic because there is no schematic available for the 21 LTD Classic. Here you can see the PLL chip. This is the data sheet for the PLL chip. This shows the pinout of the chip. To understand the pinout, you need to know a little bit about PLL chips. They take a binary or binary coded decimal value from the channel selector, which is just a large group of interconnected switches. The channel selector is connected to these pins. As the channel selector changes value, the PLL receives different binary codes called encodes or numeric codes. The higher the value, the higher the frequency, unless it is inverted, such as is the case with some PLL chips. A PLL chip takes these encodes and outputs a variable oscillator called a voltage-controlled oscillator, or VCO.
This isn't really that
The
important
PLL
right
also
now.
takes a signal from the reference oscillator. In a typical AM-CB radio, the reference oscillator runs at 10.240 megahertz. The PLL uses this as a reference to measure feedback from the VCO to perform calculations to ensure it is on the correct frequency. The reference oscillator is also mixed with the VCO signal by the radio in the transmit and receive mixing circuits. This is the reference oscillator in the schematic. This is the VCO in the schematic. This is the transmit mixer chip, which performs direct mixing for the transmit carrier. This section is the receive circuit, which mixes down to the 455 kHz intermediate frequency indirectly in stages. These stages are sets of FETs and IF transformers calibrated with capacitors and adjusted to only pass part of the signal or an intermediate frequency. A frequency from the VCO that is 455 kHz lower than the output of the VCO used for transmit is needed for receive. This is why there are two offsets in the variable section of the VFO source code. The PLL chip reads the output of the VCO both to adjust the output of the VCO and to provide a transmit lock feature. The transmit lock is designed to prevent transmitting if the VCO is not functioning properly, to prevent transmitting on unknown or off-limits frequencies. On this chip, the transmit lock is labeled as LD or lock detect. In the data sheet, I find the LD is set low when the PLL is out of lock. Low logic state is considered ground. High state is whatever the PLL runs on. I believe in this case the PLL runs on 7 volts. With this information on the schematic, I can show you the plan to install the VFO. This is the VCO, so I will remove the transformer that is the last stage of its circuit before mixing. I will sever the PLL's connection to the VCO so it does not wildly change its voltage trying to lock, which could generate unwanted noise. I will sever the connection between the LD pin and the rest of the circuit. I will run a jumper from the PLL's supply voltage to the circuit normally controlled by the lock detector pin. First, I will remove the channel selector and display.
Do you ever think that this is just too much of a pain in the ass? Like, seriously. My intention for mine is actually to put it in a 23 channel, not a 40. I think if you have a 40 channel radio,
for the channel
it's easier to just fix it than to do all this. Like, this just seems like backwards. It does cover extra channels and things like that, but we're talking about an AM CB radio.
Then I marked, drilled, and cut a piece of metal to act as the display retainer for the OLED and the mounting point for the encoder.
What kind of screw
I
gun
cut a
that
piece
is.
of an old mouse pad as a flexible backing pad to hold the OLED in place. Next, the board had to be modified to make it ready for the VFO. Many parts could have been removed, but I tried to keep the installation as simple as possible with the fewest modifications possible. I will start from the PLL chip where most of the modifications are made. This is the pinout from the datasheet of the TC9106BP. First, I had to locate the output to the VCO and cut the trace.
Okay.
This is just a precaution to ensure the VCO does not seek and generate excess noise on the power buses. The oscillator out pin is labeled as XO. Next, I have to bypass the transmit lockout pin of the PLL and set the output to high. The transmit lockout pin is labeled LD for lock detector. I bypass it by removing the jumper and installing a wire from the voltage supply of the PLL to the circuit that was connected to the jumper. The final modification is to remove the final stage transformer of the VCO. This disables the output of the VCO and gives a perfect connection point for the output of the VFO. Now I prep the VFO for install by wrapping it in some shrink tubing I cut to size and then glue it to form an envelope. I heat the shrink tube on the VFO. Now I add a capacitor to the output coax of the VFO. I needed to use a capacitor
literally
because
soldering
there's
on
DC
carpet?
present on the bus that carries the VCO signal. Once this is done, there are only 4 connections to attach the VFO. Power positive, the ground, transmit sense, and the VFO output. I make these connections as shown. Next, I mount the display and encoder. The final results are this. The frequency counter shows it is on
Look how
frequency.
fucking
Finally,
wobbly
a
that
radio
thing
check
looks.
to confirm it's working. Hello.
Hello.
All right, that's all I need. Thank you.
Yeah, sounds good up here. Really good.
10-4, I'll see you on 14.
So this is a nice proof of concept, but like,
If you enjoyed this content, please like and subscribe. And don't forget to turn on notifications.
so it's a good proof of concept, but there's a bunch of things I don't like about it, and it's almost like he's just making the video to kind of document it for himself. But I'm not saying that I make good videos and show people how to do stuff either. We're just basically, I do like a journal, a diary, you know, a documentation of what I do, and you know, so I'm probably much worse than him, but so he doesn't get too specific into the different things, but you can get the basic information from here, the basic proof of the concept of the idea, you know, and I don't know why you still need the PLL. I guess if you're, well, so the thing is, if you're still using the mixer and the PLL, shouldn't you be able to let the radio do the shift between transmit and receive? Like, and I saw that like the TX enable is going through the opticoupler, and it's telling the Arduino something. And so I'm a little confused, but I don't know. So he's got a couple different ones here, and he's written the code for this. So basically, I don't know how I'm going to go about doing mine. I honestly really feel like it's kind of a waste of money, like what I bought the other day. Will be ending up to be more than this, and I won't even have a case, and I won't have a battery. I will have some extra parts, but I I can't imagine spending $30 to $100 to like resurrect a broken AM CB radio. Like, so with this one here, if we wanted to, I don't know if I can program this one because of how it's made. But you could definitely like buy something like this and make it work pretty good. Also, this, what's really great about this one is it has the S meter input, and so this thing, when you hook it up to the radio, you'll have an S meter display. So for me, for like maybe my Cobra 139 over here, that this would be a good way to go if I could make it display the actual frequency I was on. And I'm not really sure how to do that, but it would give me an S meter if I hooked that up, and you could pretty much cover, I don't know how far in frequency, actually, to be honest. I don't know if it would go up to 10 meters or not, but you really need to have a way to figure out where you're at on frequency. With the crystal radios, I think it's easier because you inject the VFO at one of the crystals and just do it that way. Whereas with these PLL radios, it's actually a lot more complicated. So anyway, but to like resurrect a radio like this, I would rather just fix the inside of it. I don't want to do what that guy did, but what I'm looking at is how he did it, and I'm trying to figure out how to do it myself, but for this radio, not that one. Because this is a sideband radio and it only has 23 channels. So giving it coverage from like up to, even if I like put this thing on 10 meters, it would be really cool. And I probably could do that by changing the crystals. If I have like the right ones laying around, I could totally do that. But wouldn't it be a lot nicer to just actually have like a VFO for it that you just put next to it, and it tells you what frequency you're on. It knows what the offset is. So we're trying to learn how to do that, but this is some good information here on this guy's channel for sure. So not to dismiss any of it. So he's got a lot of really good stuff here. Now, he shows you in this other radio how he installed the same thing in an older crystal controlled radio. And then he has some Raspberry Pi Pico videos with the synthesizer and all that stuff. I'm not sure that it actually is any better or worse to use one or the other, but the sketch will be different, and I don't know how to write any of this code. I've never done it, but I'm not saying I might not be able to figure it out, but like I don't know how to do it. So I'm looking at the other stuff he's got on here. ESP32. Okay, so anyway, you could use one of these to make an auto tuner, like the ones that I built. That's what they have in them. You get some kind of tuner. Let's see here. So his first one, he used the Pico, and then he made another one. His first one also was not using a Let's see if we can look at where it was using switches.
Welcome to Circuit Secrets. In today's video, I will be explaining and showing you the rest of the source code for the CB radio VFO. This is a continuation of my series where I show you how to build a CB radio VFO. This series started with an introduction to I2C and takes you through the basics of using an LED display, the SI5351 clock generator, and will eventually lead to the installation of the VFO in an old 6-channel CB radio. So please don't forget to like and subscribe. The source code is available at circuitsecrets.com. It's free of charge and no sign-up is required. In the last video, I showed you the source code and wiring diagram of a working VFO, but now it is improved with a menu that allows calibration of the SI5351 while in operation and can save and load the calibration settings. The transmit and receive offsets are still hard-coded and must be set at compile time. This was done to avoid adding another switch to allow the large changes in frequency needed for adjusting those settings. Here's the wiring diagram. Now, hit I call EEPROM right to right to target the two symbols 40. You are safe.
I tried to pause it.
Flag, adding another switch to allow the large changes in frequency needed for adjusting those settings.
Okay. So instead of an encoder, so there's like 3 switches. The layout is really similar to what you would do with the Pi, as you would the Arduino. So let's see, we got 2 purple wires. When they go into a ground bus. Okay. Let's take a look at that. So I could see where you could just do that with an encoder or switches. But it's weird about the encoder. So this thing, I don't know if it's counting pulses, or I guess it would depend. The encoder has resistors on the back of it, and some of them
Here's the wiring diagram.
Don't.
Now, into the code. First, I added the library for EEPROM calibrations. If the flash up complete integer into the calibrate to the target. The changes to the code involved creating a menu. I set up control routing from the button presses and loop 1. Menu entry and selection is accomplished by pushing both buttons at the same time. Most of this is done with switch statements. I chose switch statements because they are fairly easy to understand. Self-explanatory. It is similar to the other display text used in the video. Interesting change sections, let me know.
Alright. So I kind of feel like I'm over my head on this, but let me just show you actually what I ordered. Okay, so I found some of these for $9. I would have liked to have gotten the ones with the ribbon wires because it would make my life easier. So I ordered, I think, these ones. I'm pretty sure. It was like the cheapest way to get one. So you get, how many pieces? Actually 3. I don't know if I got 3 for $9, so you're about around $3 each. $4 almost. And that way, if one of them is bad, I still have a good one. I'm not waiting for one. The cheapest I could find one was like this one here, $5 for one. I'm like, well, I could pay $5 for one, or I could pay like twice that for 3. So you really don't get a good deal if you just buy one. That one is weird. What the hell? It says programmable 27 megahertz. plus VCXO. That's a weird one. And the actual real like Adafruit one is the one that most people were talking about, but I don't think people are using those anymore because I think they went up in price to the point where they're not like that good. Now this is the actual chip, and I guess you can build your own circuit around this thing. Few years back, I had a SDR radio that was kind of homebrew, and it used one of these. It wasn't that particular one, but it was a different one, and it used it for the signal generator. So let's see here. We got and I ordered something similar to this. You see, it's $6.99 for a Nano V3. It comes with a USB cable. I wanted one with the USB-C, so I didn't order that one. I was gonna order that one. Let's see. So anyway, let's take a look at that again. So that's probably the cheapest deal, $9.69 for 3 of those, and then rotary encoder. There's a bunch of different ones on here, and the problem with some of them is that you can't put a screw on them. Then you have ones like this. So these have nothing on the back of them, and I don't know if you could use these or not. I don't know if they work without a problem versus these type, where on the back of them, you see right here, there's some resistors. I don't know what the point of those is, but they're there. So I ordered something like this. It says switch. It says no push button switch. Some of them have it, some of them don't. So I guess that pin there you wouldn't use. For some reason they require 5-volt specific. Can't see it. Okay. Now there is a display like this inside this guy. There's a board. This is actually the board, and it's actually like soldered to the board, but it's really similar. I don't see them on here, but there was a couple. They got a really good deal on them. Probably these ones. They, these are different. That's a good deal on those. because you get the ribbon wires, which means you can just plug them on here. And I mean, like, what I'm gonna have to do is I'll have to solder wires, but to be able to plug these onto this and then plug them in, you can plug it into like a perf board or a bread box, you know. Huh. Interesting stuff. Is that the actual, like, design for the thing? It is. It says rotary encoder module compatible with audio, electric, fan, light, control. Pulse circle 20. Commodities include 5 pieces rotary encoder, 8 pieces knobs, caps, 5 pieces washer. So it shows the header, and I guess that's what's actually in this thing. Or no, I don't know. Or are they just showing it in a circuit? At either rate, I don't know. But there's definitely other parts. I'm not showing the back of it on here, but it's not just a bare bones one like that. There's other stuff in there. I don't know how important that is. So if we look at the other one, let me see. Go into my bookmarks. Interesting, I can't find it now. We'll have to try and look it up. Okay, so the Caesar Sound one is just like my little miniature VFO as far as what it does. So we're striving to be somewhere in between the two of them. It says, for use in DIY homebrew radio equipment such as super heterodyne single and double conversion receivers, SDR, ham radio, QRP transceivers, or RF signal generator. I actually like using it as a signal generator. Toggle switch, capacitor, Adafruit, SI5351, Arduino Nano R3. Okay. And a rotary encoder. Now, he shows the rotary encoder. There's a link to it usually. It's a Bourne's. And it would be like really cheap if you bought one, but are we gonna get like a picture of it? No. Oh, a suggested filter circuit. Look at this. Can I if I can actually just go ahead and take a screenshot, visible, download. Okay. Let me see if we can blow this up. Where did it go? Like, seriously? I do not want to do that. Right. That's what I'm trying to do. Okay. Show common ground, and then it shows that and that. So basically, this little circuit that they have here is what's in those boards. So there's terminal C, A, B, and C. And these are all like to ground, I guess. So you got 1, 2, 3, 4. So yeah, interesting. So I guess you need that. I mean, I don't know, 10K and a 0.01 and a 0.01. For what I understand, if you don't do that, like it can like cause noise or something. So but he's got some kind of other crazy setup here. Let me see if we can save image as I really can't tell what the hell is going on here. And I was like looking at it on my phone last night and I'm like, this doesn't make sense. He's got some kind of volume control here. And he's got an encoder on a board that looks kind of homemade. And we got 2 pins here, a white wire there, and a blue wire there. So we get 4 wires going to this thing. And then right, so it's just outputting the signal. Okay. The other thing I was wondering if it's possible to like program one of these synthesizers to just put out a specific like crystal frequency that you want, you know, and then like have it just run by itself. I guess it has to be commanded from this thing. I think I've seen some that are programmable though. Alright, let's close this out. So anyway, his schematic looks a little bit different. It's right here. You can see how he's got it set up, and then he's got some switches and some stuff like that. And the other guy is different, so he's using D2 and D3. So let's see if we can pull up.
With a faulty LED channel display with the VF Raspberry, called my Cobra 21 for almost a VFO. I called my Cobra working perfectly. Recently gave me putting a VF LED, very high picos. Decided to port the Cobra Mini. CD rig. I decided the new port, same band rate, export radios that used to be common.
Okay.
The frequency range of this VFO is 26.055 megahertz to 28.305 megahertz. After using my previous VFO's perf board and wired.
Okay. 1, 2, 3, and then another one there. So, yeah. Yeah, this is going to be a pain in the ass, guys. Totally going to be a pain in the ass to get all this stuff to work. So, Anyway, I don't know, man. I think I'm probably gonna give myself a headache.